Hello, as you can see in this question, it is asked a body falls from rest in a vacuum near the Earth's surface. So, a body is falling in a vacuum. You have to remember, in a vacuum, a body is falling towards the Earth. That means the acceleration here will be g, which is equal to 10 meters per second square. Now, the acceleration is uniform when there is no air resistance. Okay, no resistive force. The variation with time t of its velocity is shown below. Okay, this is a linear acceleration graph. As you can see, there is a linear relation between velocity and time. Now, which graph shows the variation with time t of the speed v of the small ball falling in the air at the same place? Now, a ball is falling, but there is air resistance, upwards air resistance. Okay, in that case, what will happen? After some point of time, for some moment, the velocity will be, or sorry, the g will be same, 10 meters per second square. That means it will be uniform. But after some point of time, the air resistance is high enough. Why? Because the velocity is high enough. That means the air resistance will be high enough so that it will effectively resist this ball to go down. That means the acceleration will decrease. Okay. So which graph shows that for some moment the acceleration is uniform and after that moment acceleration is decreasing? As you can see, option number A, velocity versus time graph. Here you can see velocity is uniform for a while. That means g is 10 for this brief moment. That means it is uniform, and after this point of time the g started decreasing because of the air resistance. Why? Because the velocity is now high enough so that the air resistance is also effective and it is effectively reducing the gravitational acceleration or falling acceleration. So this is the correct answer. Thank you.